How do we graph secant and cosecant? Well, it's closely related to graphing cosine and sine. So let's remind ourselves, how do we graph sine and cosine? We're going to identify the amplitude, period, horizontal and vertical shifts, draw an equilibrium line at y equals d, so the vertical shift, then graph a point at x equals negative c over b, which is the horizontal shift. If it's not on the graph, then you're going to add the period until you get to a point on the graph. Remember that sine starts at equilibrium, cosine starts at a maximum. Then graph a point a period later and fill in the intermediate points. So how do we change this for graphing secant and cosecant? Well, we're first going to graph sine or cosine. Then all of the equilibrium points are going to turn into vertical asymptotes. And from each minimum and maximum, you're going to draw U's and upside down U's. Lastly, erase the sine or cosine graph. So I'm going to use different colors. First, I'm going to identify the amplitude, which is 1/2. The period, I frequently use capital T for the period, which is 2 pi. The horizontal asymptote, the horizontal shift is 0, and the vertical shift is down 1. So we're going to shift down 1 and draw our equilibrium line at negative 1. Then we can use negative c over b, which is 0, to find our first point of what would this be? This would be cosine. We're going to look at what would cosine start at? Well, cosine would start at a maximum point at 0. We're going to start at 0 because of the horizontal shift. And then 1 period later will be 2 pi later. That'll be there. And then halfway between, we can fill in our intermediate points. And then we can repeat this process. Another pi later will be another equilibrium point. I'm sorry, it'll be a minimum because this is cosine. So now now we have graphed all of cosine, 1/2 cosine of minus 1. Now we have to turn this into secant. So first we're going to find all the equilibrium points. All the equilibrium points are here, and therefore those are going to change into asymptotes. So at pi over 2, 3 pi over 2, and 5 pi over 2, we have vertical asymptotes. Second, we're going to take all of our maximum points and draw U's from them, and minimum points and draw upside down U's from them. Of course, if you wanted more detail, you could be more detailed, but this is good enough. And then, lastly, we want to erase our original cosine graph because it's only going to be the secant part that we're looking at. We're not going to actually include the cosine points. So there is 1/2 secant of theta minus 1. Here we have our amplitude is 1/2. We have the period is 2 pi divided by 1/2. So that's 4 pi. We have the horizontal shift is 0, and the vertical shift is up 1. So I'm going to start by graphing sine. Because we're looking at cosecant, I'm going to graph the reciprocal, which is sine. So the horizontal shift says start at x equals 0. Because it's sine, I'm going to start with an equilibrium point. Then we'll move 1 period later. So 1 period later than 0 is 4 pi. So there's our next equilibrium point. And then I can use the amplitude of 1/2 to fill in our maximum and minimum points here. So that'd be a maximum, that'd be another equilibrium. Now we have graphed sine. So how do we find the reciprocal function? All the equilibrium points will now become asymptotes. And each of the maxima and minima, so you can call those extrema, will have u's graphed from them. Now we want to erase everything that's the original sine graph. I can't do that perfectly, but here is a good sense of what our final cosecant graph will look like.